help the audience.
Hello, can you hear me? Yeah? Okay. Hi. So I've got this talk on GitHub, so for any of you who have a computer and want to just look ahead, then you can look at that tiny URL link there, and that'll take you to the GitHub repo. You can just clone it right now, and it says tinyurl.com/EAPC test cookbook. And while you cloners go ahead and start doing that, then I'll just sort of do a little tap dance here. Hi, my name's Belden Lyman. I'm from Shutterstock, and this is kind of a train wreck of a presentation, I'm going to say. This is I've been doing test-driven development with Perl for about 7 years now. I've been at Shutterstock for about a half year. Previously, I was with a company called Airwave out on the West Coast, and they're pretty interesting. The tool itself is it's a tool used by system administrators to manage large wireless networks. It's a bunch of daemons written in Perl that talk SNMP, whatever. It's good, but the style of development that the Airwave team does is kind of interesting. It's XP. So it's pair programming and test-driven development. And the Airwave team started out doing XP Perl about 12 years ago now. And at that time, there weren't really any good testing facilities in CPAN for doing test-driven development. So we ended up writing out a lot of those tools in-house. So I'm going to talk to you about some of the things that we used that made our test-driven work easier, and sort of show you how you can go about building out these same types of functions for yourself using things from CPAN. Yeah, I'm on Twitter also. Yes. So test-driven development is kind of an interesting topic, right? A lot of us probably think about it like this, right? Like it's it's like a horse-driven chariot, or it's a horse-driven sleigh in this case. That the tests are somehow powering, that they're dragging your development along, and I think that that's part of the story. I think that that's partly true, but I like to think about it like this: like we're going to take your code out for a test drive, and for me, tests are the first and most authoritative consumer of the code that I'm about to write. Comments, drift, documentation, lies, tests always tell you how your code behaves. And there's, I think, a distinction to be made between writing unit tests for your code and using your unit tests to guide the direction of your code. And yes, good. Now actually, I got ahead of myself. So going back to the notion of taking your code for a test drive, like when you're test driving a car, it's kind of neat, right? Like you get to play around and say like, well, do I like this? Do I like the cockpit of this car? Do I like how the radio is laid out? And since we're all a bunch of nerds, then we're going to say like, well, what's the gas mileage of this car and what's the acceleration? Like we want to put numbers on this car that we're test driving, and tests can do the same thing for you, right? Like you get to measure correctness. That's good. I think that that's something that we all get, but you should also be able to get more information out of your tests. You can look at timings of a given test file that's running. And even if all the tests pass, if it takes a lot longer to go through and run that test than it did in previous times, that probably indicates that you've introduced a performance regression, that you want to fail it. You want to figure out like what caused the change in your performance, right? Another idea that you can get out of your tests is being able to let you know when the bad refactoring has happened, right? Like, boom, you can put a test in place that says, I know the current state of my system is good. This happened recently. A colleague had written a manual bit of a regular expression for reformatting large blocks of text at 78 characters for formatting for email, which is good, and it worked fine with Unicode characters. But if you say use bytes anywhere in the file, then suddenly your regular expression breaks. And so that's a case where you'd want to put a tripwire test in place that will blow up when someone goes and refactors the regular expression, or they pull in some other library which is doing it wrong. So those are the things that you want to be able to get out of tests. But for me, the biggest thing that you need if you're being purely test driven in your development, not writing tests after the fact, but using them to actually guide you through your development process, is that your test failures have to be meaningful. So, like, how am I going to compare these two data structures here? How would you go about doing that? Like, maybe is deeply from test more, right? And that's a good way of testing, except it doesn't tell you enough about the failure, right? Like, things are very different, and if the extent of the information that I get here is that, look, things begin differing right there, then everything else that's wrong here doesn't come back to me at all, right? And in the case where got is the output of some function that you wrote, and expected is the static data, right? Then you need to know the full difference. You need to know the full way that things are wrong. When you're looking at this and you're trying to say, like, well, how exactly is this wrong? Like, how is my function wrong? Knowing just that isn't enough for you. Like, from the perspective of testing a CPAN library, tests that you're running on someone else's machine during installation time, like, that's great. You fail early and then you're done with it. But from the perspective of developing this function, which is returning, go back, there we go. From the perspective of testing this function, which is returning broken data, you want to know the exact way that you're broken. That's so there's hey, all right, cool. I like that, Doug. So this is the first slide. You'll notice that my slides talked about something in the slides directory. If you did clone the repo, then this is the file that I'm looking at now. So we can run this again, similar data structures, run it, and yep, that's exactly the failure that I claimed that we were going to see there. And there's a whole bunch of other ways of comparing these data structures. We can keep these all open and take a look. So test more, test deep. DPQ. DPQ is not too bad, right? It tells you exactly what went wrong, but it doesn't show you a diff between two things. Like, as a developer, I find myself reading a fair amount of diffs, and so more of a diff output is good, I think. So let's go and find, there's test differences, run that. Now it starts getting a little bit more interesting. So now we've got a visualization of differences, and it's kind of hard to see, but there's little splats here and here which show where things are different. So hello Madison versus good night moon. Other things are different there as well.
And what gave you that output?
This is from test differences eq or diff. This one here. And what I like about test differences is you can also tell it that you want a context diff. So we go down here, here's our context diff. These pounds are a little bit annoying.
Can you use a
look
bigger font?
Yeah, sorry about that. There we go.
And move over a tad to the right. It's getting split.
Like so?
I'm trying not that far. That's it.
Okay, thanks.
Thank you.
Yeah, so now it's a context diff. It's a little bit weird to look at because apparently I've angled it. Sorry, y'all. I'm using Emacs. I'm not a Vim guy. And then there's also a unified diff output, which is the one that I like the most. So here's the unified diff between these two. That to me just jumps out right away. Like I can read it. This is how Git diffs are coming through in my email. Like I can understand this failure really easily. So for the course of the talk, I've just generalized this this notion here into. Oh wow! I can't see the bottom of my client. For the course of this talk, it's generalized into here. We'll find it eventually. Okay, so you want to get more info out of your test failures. You can build out a simple tool set for yourself. It's really hard to find all of the preformed solutions on CPAN as working exactly the way that you need them to. You should be able to take testing libraries from CPAN, build out your own testing library that you use internally within your code base. So here's a couple more of those. Go back. There we go. Okay, so two hashes. They're identical, right? Like 1 goes to 2, 1 goes to 2, 3 goes to 4, 3 goes to 4, 5 goes to 6, 5 goes to 6. They're identical from a hash perspective. From a list perspective, obviously they're out of order, so they're different, right? You'd expect that 2 hashes would therefore be deeply equal to each other. That these 2 lists would not be, and we can take a look at that. That sounds about like, there we go. Sure, so there we go. We've got a diff between these two that says, hey, 5 and 6, 1, 2, 3. You know, you can still read it fairly well. Here's the definition of depoking. It's just pull in test differences, tell it it's a unified diff, and eager diff these 2 things. A lot of testing functions have prototypes on them, so when you're going and writing your own testing function or when you're writing your wrappers, then you'd probably want to preserve those prototypes as well. In general, I don't really like prototypes for most code, but that's why it's there. One thing you notice about this test failure is it says that the test failure was in my test cookbook at line 28, which is true. That's where the test line actually goes, where it actually occurs. This isn't very useful to you at all. This tells you nothing about the actual test that was occurring. And fortunately, there's a test. Localize this variable to bump the call stack up 1 level for how test builder is going to report the failures back. If we go and run this again, now we see that the test failure, instead of it saying that it's at test cookbook line 28, now it says that it's at the simple toolset.t line 13, which is exactly where we are. Okay, and so a lot of times when you're testing data structures, you do care about the order of things. So perhaps I do care that the 2 lists are out of order. On the other hand, perhaps I don't care, and so you might write yourself a set equal or a set OK function. So we fail the one that we expect to, which is here at line 13, and we pass the one that we expect to, which is the third test here. You can guess what the implementation of set OK is. It's pretty naive at the moment. I didn't really need to build out anything that would handle a deeper data structure, but you can certainly go through and make it normalize deeper data structures as well. These aren't functions that you might care about. These are functions that I care about. And you can just go and build your own set of functions to make your tests easier to read. When you end up with a large system, when you end up with a really good set of unit tests, Glenn was just giving the intro to Modulicious talk, and he said that the Modulicious code base is around 10,000 lines of code, and the test suite is around 9,000 unit tests over 17,000 lines of code. Like that's pretty big, right? And you've got really two very large code bases there that you've got to maintain, and you can bet that they're refactoring really heavily on the Modulicious side of it, on the core app side of it. And what you also want is to be refactoring just as heavily on your unit test side of things. If your unit tests are cumbersome, then you're not going to make choices that you otherwise would want to. You're not going to do refactorings that you want to do, or you're going to change the way that you do your refactorings because your tests are just going to have a lot of friction to them. So when you find common testing patterns that you're repeating when you're copying a test from this, a bit of test setup from this code, from this file, and putting it over in this file here, you want to take a step back from that and think about, like, well, how would I generalize this testing pattern? Like, what word can I put on it? How can I make a nice interface for this to work for me? You want to reduce the cognitive tax of your unit tests as much as possible, just as you do with your own code base. Other testing functions that I find helpful, I always screw up the fact that system's return value is inverted from Perl's notion of truthiness. And so I just have a system OK that goes and does that. You can guess at the implementation of that. It's going and saying that the exit status is 0 in this case. You could pay attention to more things out of system. You could localize $?, whatever it is that you want. But the general notion of, look, I'm going and running system command, I'm making sure that it's OK, here's a system command, and everything comes out, like, that's good. One of the things that we ran into on the Airwave project was profiling our code, figuring out places where we should be memoizing that we weren't, and then having to go in and add memoization. But you don't want to go and add a line of memoization without actually having a test that's going to fail if the memoization disappears, right? I mean, it's an easy thing to say, like, memorize this function, and you'd think no one's going to come along and remove that, but you don't know. Like, you do bump key editor, like, you do bump things in your editor, you do delete lines accidentally. It turns out to be fairly simple to write a memoize OK function. If you try to dememoize something which is not memoized, then Perl dies. So you can use that in an eval context to see whether things are memoized or not. In this case, we have one thing that is not memoized and one thing which is, and we'd expect to see that this is, this test here should fail, and this one here should pass, right? And sure enough, go down here, something expensive being memoized, nope. And obviously you don't want to change the state of your program. You don't want to just go and dememoize things in the course of testing whether it's memoized. So after you're done testing whether it's memoized or not, if it was, then you should probably go and memoize it again. This testing strategy, like, it'll slow down your tests to prove that you are using memoization, so you wouldn't want to prove memoization of the same method in a whole bunch of different places. But it is something that we've found useful and that I'm sure I'll find useful over the next year at Shutterstock. You know, proving that you've printed things to standard out or to standard error, those are also common things that you need to deal with. I tend to like standard out of as a function, you know, taking a code block. You know, these aren't really ground-shaking things, I think, to say, oh, I previewed this talk at NYPM a week or 2 weeks ago, and David Golden was in the audience, and he mentioned that Capture Tiny is better than all the other capturing modules out there. And I left a note in here to myself to do that. So there's, I guess, capture standard out, capture standard error, sure. Right, I mean, go and change the implementation now. It doesn't matter how these things are implemented. You're wrapping them, you're expressing the idea within your own context, and if, you know, when some new capturing module comes along that works better than Capture Tiny, then you're not going and changing all of your tests everywhere. You've got one spot that you're reaching in, and you're changing how you're doing it. This is how you'd write your production code. This is how you can write your tests as well. Yeah, all right, so let's go back to slides. Oh yeah, XML-OK is kind of an interesting one also. I expected there not to be anything really good for XML testing, and I was happily surprised to find out that there's test XML, which provides isXML. So if we have this rather arbitrary-looking SOAP envelope, which is for talking to some EU service and validating VAT numbers, I hoisted this straight out of a CPAN module. You know, when we have the same thing on both sides, then we'd expect that the thing I just wrote would be completely broken. Sure, why not? Sure. So we've got some, you know, got and expected, like that doesn't. They should match up correctly. If we provoke a deliberate failure, changing VAT number to cat number, then the failure mode's not too bad actually. It tells us that you know, the child element VAT number is missing, the rogue element cat number was found. It tells us exactly where in the XML document the differences occurred. It doesn't really give us the nice diff that I'd like to see, and that's okay. Like it's pretty easy to just say I'm going to take this got XML and this expected XML, just convert them to two data structures, diff the data structures, and then see how things are working out. So that would be this output here. Now this isn't too bad. You know, there's it tells us that there's cat number, VAT number, gotten expected. It's pretty well described what's going on there. I like this, but the XML test XML is pretty good for this as well. The nice part about using this strategy of converting your document to a data structure and then comparing data structures is that it applies to other types of things as well. So for instance, if you had some HTML that you really had to validate that you were sending the right stuff out, then you could do the same sort of thing. You can say XML OK of it, or you can use the isXML from test XML. And in this case, I think the difference is a little bit easier to understand from a data structure perspective. So here, yeah, it's kind of hard to understand this one, I think. Found one differences with the expected. Where am I? Up there, I guess. Right. It's kind of hard to understand what's going on. Whereas here, it shows us really easily. Look, the content of some of the body is one is goodbye world, one is hello world. That's not too bad. Maybe you'll use that. Maybe you'll use something else. So yeah, go for it.
Have you played with test XPath at all?
No, I haven't.
Okay.
Yeah, that sounds like a good one for me to have
Like
researched.
expected notes.
Cool. Yeah. Actually, I have a notebook out exactly because I knew that someone was going to say, check
One of
this.
days at Wheeler's.
Okay. Thank you. I'll give that a look. Yeah. As you can tell, my talk is kind of unstructured, so interrupt me when you have questions or, even better yet, good ideas that I've totally overlooked. So switching away from the idea of building out your test library, I think I've kind of hammered that as far as I want to. When you're writing your tests, a big thing you should care about is maintaining them, right? Like you've got to go and maintain code and test code. You've got to go and maintain your tests. Tests in a loop are really easy to write. They're really tempting. Like this is obviously a very leading slide. But maintaining test counts gets really annoying. Understanding failure modes is hard. And my core complaint with tests in a loop is that chances are each iteration of the loop isn't really a unique test. Chances are what you're really doing is you're testing a property of the set that you're pushing through the loop as opposed to testing every single member. I'm seeing some head nods, which means that some of you guys are well on board with that. I like it. Here's a really lousy and deliberately flawed Fibonacci generator. It's ignore the fact that I'm calling it Fibonacci sequences. It's just to show you how annoying these test counts can be, right? So we run this once. Now, by looking at this, it's very hard to say how many tests are going to be run, right? Well, I had 7. I guess that there were 7 things that I was testing, and it's really easy to add in the next sequence, whatever it would be, 34 maybe. Does that look right? Looks right. And now the test count goes from 7 all the way up to 8. You can do better than that. So one thing that you might do is say, okay, I'm going to have a list of bad things, and I'm going to say, for each of these, push bad. I got, well, I guess I should say my God equals Fibonacci, and so I'll say God, and that's my expected. Right, so you can do this to eliminate the loop and to express the idea that, hey, now it's just something that's happening for this entire set. So we should go from whatever it was, 8 tests up to 9, and we have the same test coverage at this point, except I forgot to reset, so things are totally busted. So let's get it better. There we go. That Fibonacci generator is, you've noticed that it's just using an incrementer, so that fib reset resets the whole thing, right? So there we are. We've got 3 things that are wrong. That's better. We've condensed 8 or 9 tests down to 1, but it's hard to know exactly what the input was and what the output was and what the failure mode is here. So you can do better again, and so that would be something like this, where you can just say, look, here's my generalization of tests in a loop. I'm going to say that if I call Fibonacci, the thing that I get back from Fibonacci, here's my got, here's my expected thing, which is coming over this entire list of things. And now I'm just going to turn all this off. Now if we run this, it's one test, and it, I think, expresses pretty clearly what's going on. At index 3, we're dealing with this raw bit of data, which is a 5. We expected 5, and we got 4. Things are busted, and same thing here. So I think that from this, it's easier for me to go back and to figure out, like, well, what exactly failed out of that entire list of events. It doesn't have to be Fibonacci sequences, right? You could be testing that files that you're writing to disk are properly encoded for whatever it is, or you could be there was a fellow who maintains a Indian calendar converter. I guess there's a bunch of different Indian calendars, and he takes a whole bunch of Indian dates and pushes them through his conversion routine to verify that it comes out with the right calendar date now. And that's a case where he has tests in a loop, but really you're testing the function, not all the different things. Mock objects are another testing strategy that are helpful to me. I find them useful when dealing with legacy code. I think it's kind of rare as Perl developers that we get to be purely greenfield. I think that we do go in and we're maintaining existing code bases or we're coming onto existing projects. And a lot of times you'll have a tightly defined interface to some module that you have to use. For instance, within Shutterstock, we do our credit card transaction processing using a module that was written by some third-party source. We're never going to change how we interact with that module. We're always going to make the same method calls to represent here's what a credit card transaction looks like. We're not ever going to go and refactor this third-party module. But we might change the way that we use it. We might go from having like a very procedural use of the module to having more of a data-driven use of the module. So in a case like that, it's helpful to be able to say, well, the module isn't here anymore. Instead, it's just this object, and I can interact with this object, and it'll still pretend to be this module's object, and it'll record everything that happens to it, and you can make assertions about how you interacted with that object. So you're axiomatically saying, here's how I'm interacting with this module. It's not really all that hard to go and build out your own mock object framework. It's pretty few lines of code. So here's the function that we're going to go and test, which is this, lame URL to JSON, right? So we're going to get a user agent. We're going to tell it to go and get whatever URL with whatever params. And if it's successful, then we want to decode the response content. Otherwise, we're going to get back an empty hash row. So there's a couple different things that we're dealing with here. Like we've got this user agent object that we need to talk about, and we've got this response object that we need to deal with. And the user agent has a get which needs to do something, and the response object has this success and this content to it. So here's how you can represent it in just as a single object that's it's pretending first to be the user agent, and then it's going to pretend to be the response object that comes back from the user agent. So as the response object, we need to declare whether we are successful or not, and as the response object, we need to have some sort of content to ourselves. So this is us acting like the response object. We also need to we need to get ourselves in place. So when someone calls LWP user agent new, instead of getting back this LWP user agent object, they're going to get back this thing that you just went and created. So this kind of small mock object class that I wrote has an auto load on it, which, no, let's go and find it. Pardon me. So it has an auto load on it, which is either going to return a predefined response or the object itself. So a predefined response in this case would be, look, I am successful. So for instance, I need to be able to control is success here. So I have this predefined response that I'm going to say, look, is success is going to be true. In the event of get, I haven't said that this mock object has any get about it at all. So when we look at that auto load, then we're just going to hit the auto load for the get, and we'll pay attention to what happened to our mock object during our auto load, and we'll also return the mock object back out, which is how we're able to pretend to both be the LWP user agent and the response. This isn't like brilliant, like this is all very straightforward Perl stuff, right? And so you can I think the neat thing about it is sort of thinking about your tests in a different fashion and saying, I wish I could do that, and then realizing, well, yeah, of course I can. Like, of course you can go and do that. Right. Okay, so we've got this install at for our mock object, which is also just going to go and cram ourselves off into that fully qualified method name. I think is why I called it FQMN. Excuse me. Okay. We've got our mock object in place. We can go and call our function and say, hey, here's this, and we should see that when we run it, we've gone through URL to JSON, we've asked for an LWP user agent object, we've gotten our thing back, it said that it is successful, it says that it has this content, and we get back, hello world, it's correct. If we, change it to say something like this, then we get a failure mode, exactly what we expect. It's not hello world, it's it got back hello Madison. We can update the mock object. It's represented here kind of strangely. About halfway through implementing mock object, I realized if I were actually using this for myself that I wouldn't be able to mock out any class that has an install at method on it because the mock object itself has that. So then I decided, like, well, I'm going to be able to represent updates in some different fashion. It overloads the subroutine dereferencing. So when you ask for subroutine dereference, then you get back this sub, which is going to get in these args, which just goes and updates the canned responses that the mock object knows about. So we say, hey, look, now you're a failure, and we just check ourselves, make sure that we set that to be a failure. This task more properly belongs inside of a test for the mock object class. It's misplaced here. So then if we go through and exercise URL to JSON again, then what we get back is an empty hash ref we entered into that other code block. That's kind of the bit about mocking out objects. Go for it.
Are you aware of the test mock object module on the CPAN?
I am. In fact, I think the author.
Someone's sitting here.
Yeah. The author's sitting in the room. I am aware of that. I've used it in the past. It never feels like I'm writing Perl code when I use test mock object. I think that we ended up with 3 or 4 different experiments of how to represent that same thing within the Airwave code base, and none of them really gained traction within are testing memes. So that probably means that mocking out objects is sort of a strange strategy to begin with. You're going to end up writing some fairly strange code, no matter how you slice it. So yeah, I am familiar with it. I find it easier to use other tools than that.
I mean, in fact, your makecloud.pl requires it.
Yeah, yeah. Well, yeah, that's true. And that, yeah. But what you're saying is that so
There it is.
yeah, as part of going through and figuring out, well, what of the different things do I want to talk about here. I've pulled down all sorts of different packages and installed them in a local lib. Test mock object is definitely there. You know, I mean, it's part of my toolkit, right? It's not the first tool that I'm going to reach for. I'm not always going to reach for a monkey wrench. You know, sometimes I'll reach for a vice grips.
Yes.
There's a Ruby module that lets you record your web request and then save it off and then use that as your mock results later. Is there any pro equivalent of that?
I think www.mechanize handles some of that. Can anyone think of anything else that does that?
Web scraping proxy that records everything, but it's kind of old and hard to use.
I think that there's also some www.mechanize plugin that'll turn your interactions into Selenium tests that you can then go back and replay, which is kind of handy. Although I saw the lightning talk for Testify on day one, and I think that looks like the direction that I'd rather go in if I were building things from the ground up. Okay, any more questions about my random ideas about mocking objects? Cool. Okay. Yeah. Okay. So another technique that you hear about, Randall Schwartz talked about this yesterday during his lightning talk, is monkey patching, right? And there was a small example of that in the mock object. Like when I said, hey, I've got to go and install this thing so that when you call LWP user agent new, you're actually getting back my thing. At some point you've got to go and hijack a bit of code. It's just kind of part and parcel. So, you know, we've got some package somewhere beyond the sea. If we call that, then we get some Bobby Darin lyric. That's pretty good. If we want to swap that out so that we get some Judy Garland, then we can do that too. This isn't too bad, and from an ease of typing it out immediately perspective, it's right there. I think as Perl developers, we tend to fetishize the symbol table a little bit, and I think that it's a pretty good technique to go in and be able to poke at that. Like you learn a little bit about the internals of the language at least. So this is okay. It doesn't answer any questions. For instance, if you wanted to know what arguments were called or what arguments were passed into somewhere, then you'd need to write your own argument capturing stuff in here and then be checking it after the fact. Fortunately, there's a Pro module which goes and handles all the weirdnesses of going in monkey patch